Hello and welcome to the video. This is a quick video on one of the specific functions of an HTX powered radio. It's aimed at those of you that are relatively new to HTX, might be coming to HTX from FreeSky, Futaba, Spectrum, or maybe you're brand new to the hobby. Now there are links below to the rest of the videos in the series, as well as more advanced stuff as well. Don't forget you can find content by just looking for the thing you're interested in and adding Painless 360 to your search term here on YouTube. So let's jump on the bench and let's talk about the topic for today. So this time it's all about how to set up a basic plane model here in HTX. I'm also going to be using Express ELRS. I'm going to be using a module in the back, but your radio might have Express ELRS or inside already. To be honest, Express ELRS is becoming the default for most of these kind of radios that are shipping now, and although modules can be put in the back of the bay for different things, Express ELRS has a couple of little wrinkles, so it gives me a chance to show those too. Now the model that I'm going to be using for this demonstration is this Nano Talon here. Now this Nano Talon is going to be fine for what we're doing. It has a V-tail and it also has one set of controls or connection for the ailerons in the wings, so that's a Y cable. And it's important before we get too far into this to know what the kind of model is that we're going to be playing with. And knowing the fact that we're going to need 4 outputs, one for the motor, one for the ailerons that's connected via a Y cable, and also one for each of the V-tail servos, that means we're going to need 4 overall, so we can pick a PWM receiver for Express ELRS that has 4 of those. Now obviously if you're going to be using something like a flight controller like iNav, go and check out my iNav for Beginners series. I go through all the setup, all the things we're going to go through here, or the vast majority, you're not going to get involved with. The setup is a lot easier. All of the stuff that we're going to do in the radio is kind of set up in iNav instead. So let's first of all create a model. Now we have a rough idea what the model is that we're going to be putting in and setting up. So let's come out of here. Let's go into Manage Models, click on New, and we're going to say a new model. Now we're going to use a wizard here. If you don't have a wizard, it isn't a disaster. You can actually go through, and again, I've shown everything that I'm about to show so far in this series. If anything that I'm doing here on the radio isn't making sense, go and check the other radios in this HTX for Beginners series. We'll go for wizard and we'll go for a plane. It's going to ask us now, does it have a motor? Yes, the motor channel is going to be channel 3. It says, do you want a safety switch? I would say yes. I would have SF, so we're going to go to the next one. Number of ailerons on your model, there's 2. That's actually not quite right, is it? There's only 1. So if I select that and take it down to 1, because it's 2 with a Y cable, that's going to make that easier. So that's going to be channel 1. Next, does your model have flaps? Nope. Pick the tail configuration. Let's change that. That's going to be, let's highlight it, and it's going to be a V-tail. So it's going to be channel 2 and it's going to be channel 4. So we'll say OK. Next, does your model have retracting landing gear? No. Add additional settings. Now this is great. This is something that didn't used to be in a lot of these wizards, and I would always make sure that you add it. But it's going to add expo, and we're not going to add any dual rates for this. I tend to keep things simple for simple setups. So motor channel is going to be 3, aileron is going to be channel 1, V-tail is channel 2, V-tail left is channel 4. No gear switch. There is an arming switch on SF, but we can change that around in a minute. So we're going to hold model successfully created, hold return to exit, and now we have a new setup. So this is how it's set it up for us. Let's go into the model. We'll give the model a name. We'll call it Nano Talon. I would recommend having at least 1 timer. The mode that you want to set it up, you can have it as whatever you want. I would potentially have it on an arming switch. Let's set it for how long you think the plane's going to fly. It's set for 6 by default. Let's see if we can take that up a little bit, because it's probably going to fly for longer than that. Let's just give it 10 minutes to start. We're going to set up external CRSF. That's going to turn on the module here at the back. So now the light is on and pulsing. That means we're going to be able to bind the channel ranges and the things with Express ELRS we'll get into in a minute. The only other things then, in input, there should be exponential added to the main controls. 30% is what it's added by default. If you wanted to change that, you could just come in here and you can change the amount of expo just by clicking on that, but that looks pretty good to me. Next one then is going to be the mixer. The mixer has set up most of the things we need. So aileron is going to go in channel 1, 2 is going to be a V-tail, 4 is going to be V-tail, and 3 is going to be the motor. That looks pretty good to me. We'll come into here and we'll play with all this in a minute. We'll be adding trims to sub-trims. Only other thing then, we've got an SF or an override switch, a throttle cut, which is great. Now I'm going to set up an extra bit in a minute. So I'm going to want, whenever this switch is not in this position, I'm going to want it so when it's like that, but actually I'm going to invert it to override channel 3. So you can see here it's going yellow at the top, and the way that works, if we just come out of this and we look at the channel monitor, as I flick the switch, you see at the moment it's not doing anything. However, 9 minutes. That started the timer. If I set that to high, then I have my throttle set. The only other thing, of course, is because this is Express ELRS, we need channel 5 to be set so that when it goes into a high position, we're in good shape. So I'm going to have it, so again, it goes into SG. There we go. And that now means that this channel, which is my throttle cut, so stopping the throttle from working, middle position, still stopping the throttle from working. When it comes in the high position, which is going to turn Express ELRS goodness on, we now have throttle as well. So that is most of the stuff done. So it's time to go into the system, go into Express ELRS and go and bind the receiver. So let's look at that bit next. So the next job then is to do the binding of the receiver and do a little bit of the setup. Now, because we know we only need 4 outputs, that's going to be 1 for the aileron, 1 for the throttle and 2 for the V-tails, we can get away with something like this here. This is actually a Radio Master ELRS. It's a very thin long receiver, which is perfect for this kind of setup. Only has 5 pins presented, so we'll need to make sure that the channel 5 that we're currently using for the throttle hole isn't going to get in the way. We can do that in a second, but a couple of things we need to do. First of all, we need to bind it to the radio. I've got a full video. I'm going to put a link down below if you want to go and check that out. This is actually set with a binding phrase on it. Now, the way that I do this on the bench before I plug it in. I've just got a battery eliminator circuit, something like this 5-volt UBEC, and I'm going to plug it into the receiver on any of the pins. The receiver is going to power up, and then what we're going to do here on the radio, we're going to go into System, Express ELRS, and then what we're going to do is we're going to scroll all the way down, and we're going to click on Bind.
Telemetry connected.
And we have the telemetry connected. The LED has gone solid. We are now talking to the receiver. Only one other thing to talk about here. I have got the switch mode set up as wide. Now, by default, the first 4 channels, let me come all the way out of this, you can see it. The first 4 channels that we have, which are your standard controls, are the ones that are kind of full resolution. That's going to be fine for this. Actually, we don't necessarily need it on wide, but if you want channels 6, 7, 8, 9, etc. To be full resolution for things like servos, then you need to set it to wide. There's also hybrid, some other modes. Again, I'll put a link down below, but for this simple setup, just set it to wide in there, and that's set. Now, the other thing we can do then is we're going to have to connect to this. to make it so that the 5th channel on here is not outputting channel 5, because we're just going to use that 5th channel to arm the model like we've got set before. So what I'm going to do is I'm going to power off the receiver, turn off the radio, and then what I'm going to do is I'm going to repower the receiver, and I'm going to just let it sit there on the bench for about 60 seconds, and then it'll create a Wi-Fi hotspot. So let's look at that bit next. So now the receiver is in Wi-Fi mode, we should be able to connect to it. If we open up all the Wi-Fi networks, we'll see one called Express LRS RX. We'll connect to that, and if it asks you for a password, it's Express LRS, all lowercase. When this opens, we're actually going to be looking at the configuration on the receiver. And there's a couple of quick things that we need to take a look at on here just to make sure that we're all tickety-boo. We can, of course, add a binding phrase, which will make the binding super duper easy. So I'll add a quick one here just to make sure that it is going to be saved. They also then, in these other options, if we go into model, then here we can decide which channel is going to be output on which set of pins on this particular receiver that we're playing with here. And crucially, what the failsafe position is going to be. And we'll come back to this at the very end, but by default, the ailerons are going to be at 1500. If you remember, channels 2 and 4 going to the V-tail, they're going to default to 1500, and the throttle channel is going to default to the lowest value, 988, which should stop the motor from running in the event of a failsafe. The other things down here is that at the moment, channel 5, which we set up as a channel cut, is currently exposed as a channel. Now, for things like PWM, for the time being until Express LRS decides that we don't have to do it this way, I personally would recommend just having this as channel 6 and then having that output as channel 7. There is no point in using channel 5 on this. It means that in the future, if we want to use channel 6 or channel 7 for anything, we can do that. So we're going to click on set PWM outputs. That's going to be good. Also, the mode here, we can change the mode of the speed that's going to run at. Analog servos are going to be 50 Hertz. Digital servos will be 100 Hertz or above, but we'll leave it at 50 Hertz for now. That's all good. I'm not going to invert anything. Let's just go back into options and then just say save and reboot. And then we are now going to be able to have a look at putting this inside the model. Now, in a receiver like this, we need to figure out which is the ground pin, which we've kind of already done because we plugged it in and powered it, but you need to be careful of that when you're plugging everything in. Obviously, the outputs are clearly marked here, 1, 2, 3, 4, and 5, and we've just mapped those in the Wi-Fi interface. So what I tend to do, and this is a little bit of a trick that I use for bigger planes, less useful for this to be fair, because you can pretty much see where every servo is. But I write on, when I'm playing with stuff, which of the connectors is which. So that's T for throttle. That is going to be channel 3. I'm not going to plug that in yet though. I'll show you why in a minute. Here's the 2 V-tail servos, which are going to be going in. I've marked them VL and VR. Hopefully you can see that. So I think that the channel 2 is that one. Again, we'll figure this out when we put it all together. So I'll put channel 2 on there. That is going to be channel 4, if you remember, because they're the 2 V-tails. Channel 1 is going to be the ailerons. The ailerons is on this Y cable thingy, so I'm going to plug that into channel 1. Now, why am I not plugging the ESC in? Well, initially I'm going to power it from the same 5-volt battery eliminator circuit, just so that we can do all this easily and safely without messing around. I'm just going to pop that onto a spare input, or I put it on the throttle. That means that when I apply power in a moment, all the servos are going to burst into life. So let me pull the camera back a little bit and let's get all the control surfaces moving in the right direction and moving the correct amount. So let me plug in the battery into the battery eliminator circuit, which is going to power everything. And hopefully we should see everything burst into life.
Telemetry connected.
That's promising. All the servos snapped into position. Now I just need to check everything one by one. Now luckily the controls are more or less in line, but if I move the aileron, we can see two things. First of all, the control movement is way too much and it's backwards. So how would we fix that? Well, I'll go into the model menu, I'll go into outputs, I'll go into the aileron, which is channel 1, I'll say edit, and I will invert it. Now that means that it's now working in the right direction. So that's easily done. The other thing we can do actually is we can change the minimum and maximum on here depending on what we actually want to go to. However, for something like this that's as simple as this, I would just actually go into the mixes, go into aileron and say edit, and I just reduce the weight, maybe 70%, a bit more. That's a bit more than that. That looks good to me. So the ailerons are all good. That's the easy part. Let's have a look at the V-tail. So if I pull, and the way I tend to do this is I just pull the elevator down. So that one's moving in the right direction, that one isn't. What about the rudder? Okay, so we've got all kinds of wackiness going on. The way that I do it when you have multiple things like this all connected together is I actually just edit the actual mixes themselves. So we can see here at the moment that that one is reversed for elevator, and that should be channel 2 or 4. Let's see which one it is. So we're going to go into the mixer, we'll go into channel 2, we'll go into the elevator part, say edit, and we'll change the weight to be minus, and we'll see if that works. That wasn't the one we needed. Let's take that back to 50%. So what I'm doing is just changing the polarity of that particular mix. So we're working on this one here, which also means that the rudder's wrong. So I can go into then the rudder part of that, say edit, and then change the direction of that. So that means now the rudder is now working in the right direction. So my rudder is fixed, great, and I'm happy with the movement. That looks pretty good to me. I'm going to keep it as it is. However, the elevator on this one is still wrong. So that means the other one, if I go down to here in channel 4, that elevator needs to be, the mix part needs to have the polarity change. So now there we go. They both come up for elevator and they both move left and right for rudder. So we are set. The other thing we can do is we can change the trims. If I just come out of here, these control surfaces are up very slightly, which is how I would probably have them for a maiden flight, just to have that little bit of support getting the nose of the aircraft up. However, let me just show you how I would get those directly in line on both sides. So here in the outputs, go into channel 2, I'd go into edit and then go into the sub trim, and then I would start putting in sub trim until it gets in line, which I would say is about there. Similarly with channel 4, which is the other one, I go edit, go into the sub trim, it's the other way for that one, until it's exactly in line, which is there. And that now means that they are all working beautifully. They are not only they're moving in the right direction, but everything is in line with the control surfaces. So we're in great shape. Next stage then is to calibrate the ESC. Obviously, throughout everything that we're doing here, we're going to have the motor disconnected. I'm going to unpower the receiver, because now we know that all works. We can just relax about that. I'm going to unplug the aileron just to get it out of the way for the moment. And I'm going to plug in the throttle into channel 3, which is where it needs to be as we have, that's the way it's set up. So again, watching polarity, let me just plug that into channel 3. So that now means that it's going to be powered from this little connection. Okay, so there we go. So we're all ready to calibrate the motor. Now the way we're going to calibrate the motor, standard stuff. What we're going to do is we're going to come all the way out of here. We are going to make sure the throttle is at the top position. The way we do that, turn the throttle cut off, put the throttle to the highest position, and then I'm going to power the model from a little battery into the ESC. So as soon as we hear the beeps, I'm going to drop the throttle, and that's going to calibrate it. So plug it in.
Telemetry recovered.
And now when I lift the throttle, and it should stop at the bottom. Or if I'm flying and I do the throttle hold, it should stop immediately as well. That is fantastic. So that now means that's done. If I just unplug the power, that means the ESC will save that. And that is an awful lot of the hard work done. So the final job for this part is to make sure that the failsafe is going to work. I would always strongly recommend that you test this. You'd never want the first time you test failsafe to be in the air and to discover that you haven't set it up properly. Now the fact that we've actually got these values via the web interface, which should take the throttle down to 0 and all the control surfaces to 1500, should be enough for the first maiden flight. But let's just check that that's actually working properly. So let's power the model, and what we're going to do is we'll get it running.
Telemetry connected.
So I'm going to turn off the throttle cut. I'm going to start the motor, and then I'm going to turn the radio off. Be ready to unplug if this doesn't work, and this is why we don't have the prop connected.
The servo is still connected.
It's going to say, are you really sure? And as the radio disconnected, the plane went safe. Always do that with any model before you take it to the field. Let me just unplug that. That then means that if in the event there's a problem, the plane isn't going to fly away out of our lives forever. So that is the main setup bits done. You'll notice that the control surfaces have popped up a little bit. That's because, again, they've gone back to 1500. So let me go back on the bench and give you a final couple of pro tips for this kind of setup. So the first tip is when you set up using the modern wizards, it'll also set lots of kind of warnings for switch positions and stuff. I personally don't like them, or if you want to change them, it's not too tricky. Go into the model setup, scroll down, go into pre-start checks, and here you can actually decide what position you want the radio to check that the switches are in. If they're white like this, it means that they're not checked. If they're yellow with a particular position, it'll want them to be in that position before the radio will start. Handy to have in case things like your throttle cut isn't in the right position for safety. Next thing then to talk about is the fact that I would also set up something called instant trim. So if we go into model, go into something like special functions, at the moment we have a throttle cut set up. I would also set up on the next special function, usually I have it on the spring-loaded control. That's a great one to pop it on. Set it for something called instant trim. Make sure it's enabled. The way that works is as you're flying around, you may find that, the way it normally works is that as you're flying, and I have a whole video trim masterclass that kind of goes through all the different trim things, but while we're talking about this, there's a cool one. Rather than you flying around and maybe realize that it needs roll in this direction, so you take your finger off and you kind of click it across, or you try and do cross trimming or that kind of stuff. The cool thing is you just hold the stick so it's flying straight and level, and when the sticks are in that position, you just hit the momentary switch, and that will instantly save the trims from that stick position into the trims. And then you can just maybe get the odd little bit of correction with it. Instant trim is amazing, and I would recommend, if you're not using flight controllers, set it up all the time. Once you have flown and all the trimming is done, then I would recommend, final thing, I would come into the outputs, click on add trims to sub trims. That's going to take all of that trimmed position information from these trims into the sub trims so that that is stored, so that all you have to do is make sure the trims are in the middle position before you fly every flight, and then you know you're set. You might need the odd click one way or the other depending where your central gravity is, if your battery isn't in exactly the right spot, but it just means that normally when you start, if your trims are showing on the screen in the middle position, you know that you're ready to rock and roll. And the very last thing that I would do once you've got your model trimmed is go into the channel monitor, and you'll see here that channels 2 and 4 are not at 1500, the middle channel position, and that's because we have sub-trimmed them. We've also then hopefully flown and trimmed them into the perfect position, but you can see here you can actually read off exactly what the channel positions are. Channel 2 is set to 1643 and channel 4 is set to 1398. For me, I would then go back into that web interface and just plug those two numbers in as the fail-safe position for the receiver, so that if it lost control, then the aileron, the elevator and the rudder all go to a neutral position. Some pilots like to have a little bit of down elevator, a little bit of roll left or roll right, so it gently spirals into the ground, however you set it up. But I would say the very last thing with Express ELRS is just go back onto that web interface, plug those trim numbers back into it for the fail-safe stuff, and you've set up your first plane with HTX and Express ELRS. Thank you for watching my video. Check out the playlist, and adding Pedantry 360 to your search terms will help you find my content. If you haven't done so already, please hit the like and subscribe button. It helps a lot. You can support the time I spend here answering questions and helping others by using the links in the video description.